Let's build some smart contract and let's make the NFT bridge a reality.
Next step.
We are going to start with the Bridge NFT smart contract. And the Bridge NFT smart contract, it's no different than an ERC-721 collection smart contract, a contract that I hope you're familiar with, okay? This smart contract, however, is going to have a couple of enhancements. We need to only allow the owner of the smart contract to call that particular Bridge NFT smart contract, because we don't want anyone minting NFTs out of that smart contract. It's only going to be the owner of the Bridge NFT smart contract, okay? We are also going to build the Custodial smart contract. The Custodial smart contract is a smart contract that we have to deploy across all the blockchains that are going to participate in our bridge. So let's say we want to allow users to transfer NFTs from Ethereum to Binance to Polygon to Avalanche to any other EVM compatible blockchain. We need to deploy a custodial smart contract to each blockchain along with the source blockchain. And when I say the source, this is the source of your NFT smart contract. So if you have an NFT collection smart contract deployed on Ethereum, that is the source blockchain participating in the bridge. Okay. We also have to deploy the Bridge collection NFT smart contract. This is the smart contract that is going to duplicate the NFT that is being transferred on the bridge by the user. Let me explain. I, as a user or as a holder of an NFT in a collection, I hold token ID number 10. For example, I invoke the bridge and I want to transfer that NFT to Binance Smart Chain or Polygon. I need to be able to send that NFT to the vault. In this case, to get that NFT in custody, but I need to provide the user the copy of that NFT on the destination blockchain so the user can interact with it any way or shape or form they want to, okay? The moment the user wants to move that NFT to another blockchain, it could be the source blockchain or it could be any other destination blockchain that we are allowing in the bridge, right? Not a problem. What I want to do, I'm going to retrieve back that NFT. I am going to retain that NFT and we will transfer the NFT from the destination vault, custody vault smart contract onto the wallet at that destination. Let's go ahead. Let's build that smart contract. And after we're done with that smart contract, we will build the Bridge NFT smart contract. This is a simple ERC-721 with certain features, okay? Let's go ahead. Let's make this happen. Let's go. No time to waste.
Let's create the NFT Bridge Custodial Smart Contract. Item 1. Write a function to retain the source NFT in Bridge custody. When a user initializes the NFT Bridge, we need to first obtain custody of the NFT that a user intends to migrate. Let's code a function that will, number 1, obtain user approval for the custodial smart contract to trigger the NFT move to the custody vault. Then number 2, proceeds to execute a transfer from the user's wallet to the custodial smart contract. Bonus, let's add the bridge transaction fees to the smart contract. We will enable the contract to receive payment for bridge transfer services using our custom ERC-20N2D rewards token.
Let's make this happen. Let's make this happen right now. Let's build the custodial smart contract, okay? We are going to start the smart contract by importing the OpenSea contracts that we need and interfaces that we need to make this a reality. So, because we want to also allow this particular bridge to accept our custom ERC20 token, the N2DR reward token, we need to make sure that we invoke the IERC20 because we will be interacting with an ERC20 token smart contract. Let's go. Let's go ahead and first of all, I am going to invoke the functions for the ERC-721. So in this case, I need to invoke the ERC-721 enumerable. I also need to invoke the receiver because we will be receiving NFTs onto this smart contract. This is the custody smart contract, the custodial smart contract. And also ownable because we need to call certain functions only by the owner of this particular smart contract. Okay, let's go. And finally, we are going to import the ERC20 interface, IERC20. Okay, so let's go ahead and do that. Awesome. So now let's build the contract name. We are going to call this a bridge custody contract. Okay, so let's build the contract name. This will be the bridge custody smart contract. And we also have to invoke the IRC 721 receiver re-entering cigar because we want to have that protection in case someone wants to go smarter than us. Okay, and we also want to allow contract functions to be called by the owner of the smart contract. So we are going to call ownable, okay, inside the smart contract. Cool, we got the contract open and ready for us to build the magic. We want to, first of all, add the price of the bridge transaction. We want to charge our users who want to transfer NFTs between blockchains a service fee, okay? We are going to call two public variables. In this case, I'm going to call the cost custom. I call this cost custom. This is the price that we are going to charge to transfer using our N2DR tokens, okay? So we are going to charge a service fee. By the way, you know what? I'm going to change this price to be 1 Ether. That's the measurement. That's not Ethereum. That's the measurement for our price and N2DR tokens. And we will also create another cost var called native. This will be public because we want to get the price for the bridge service. So then we can inject this using our JavaScript function in NextJS, okay? And on the native side, when I mean native, I am saying that this is the amount that I will be charging to bridge an NFT using the native token. You see the value that I put is very low because I am using testnet and I don't want to run out of tokens just because I am paying to test the function, right? So I just put a very low number so I can, you know, test it as much as I want, okay? The first struct that I gotta build a struct. The struct that I have to build. This is very important, okay? We are going to build a struct called custody. What am I going to store in this struct? I am going to store the token ID. This is the NFT token ID, okay? So if a user decides to transfer NFT number 10, that will be the token ID for that NFT, token ID 10, okay? So I'm going to make a record of that in the smart contract. Also, I want to capture the wallet address of the user who transferred the NFT because we want to use the same value in this holder address to send the destination NFT to the wallet. So that's very important. I need to know where am I going to send the destination NFT once I confirm that I got custody of the original NFT or the source NFT, okay? We want to be able to call this publicly. So this is a data that we will be storing in the smart contract. And by using mapping, we are effectively saving on gas versus just calling an array, which is a more gas intensive. So I have to store more data onto the smart contract. And we all know the more data you store in a smart contract or in the blockchain, the more gas fees you got to pay. Okay, there you go. We have to also call an event. What is the event that I need to build, that I have to invoke or emit? The word is emit. What event do I have to emit? Every time that someone triggers the retain NFT function, or every time that someone decides to transfer an NFT between blockchains and calls the transfer on the bridge, that's the event. I am grabbing the token ID, okay? And I will be indexing that because I need to be able to call that in the struct on an index basis. I need to know in which order everything came in and gone out, went in and got out, okay? I need to have an index of each token. So then I can call the whole custody mapping for that custody struct. You see where I'm going? This is the public name that I will have available for me to call in order to know what NFTs have been bridged and who is the owner of those NFTs, okay? Finally, in order for me to deploy the smart contract, I have to point the smart contract to the NFT collection that I intend to allow bridging. So in this case, I am calling the ERC721 in numeral. This is your normal ERC721 smart contract, collection smart contract, and this is the OpenSea contract. So what I'm going to do, I am going to call this right here, and then I will be referencing the var call NFT onto this particular contract, okay? And I am also going to call IRC token, okay? So this is the smart contract for our N2D reward staking smart contract, or the reward tokens. So any IRC20 token smart contract can be deployed or can be assigned to this bridge to be accepted as payment for the transaction, for the bridging, okay? Now, let's build the NFT deployment. Let's build the constructor, and this is the information that I will need to deploy the smart contract. I am going to request what's the NFT address, or in this case, the smart contract that we want to bind, we want to associate to this custody, to this vault. So any NFT that comes from that address, I am going to accept and transfer onto the vault, stored to the vault. Good so far? Awesome. Then I'm going to have a pay token. Okay, so this is the address that I'm going to accept for payments in XYZ ERC20 token. And any ERC20 token that I want to use or I want to accept as a payment to execute a bridge function with the smart contract, I am going to accept. In our case, we will deploy it with the N2D reward tokens. Okay, let's go. Let's continue. Let's build the first function. This is the retain NFT. Okay. And we are going to be building this. If someone wants to pay using the N2DR tokens, they will call this particular retain NFT function. So let's say someone wants to pay using the N2DR tokens, they will use this particular function. So I wonder, how would I tell the end user, or how would I direct the user to choose how to pay for this bridging? Let me show you. Let me open the application. Okay, so let me show you the application. So what we want to do is when a user, let me bring back the contract, right? So when the user decides to pay this transfer using the ERC20, the N2D rewards token, in the bridge, we have to split this transfer button in two. So this transfer button, what I'm going to do, I'm going to slice it in half. I'm going to have two buttons. Transfer, with N2DR, or transfer with native, or transfer by using your native token, okay, to pay it. So if a user wants to pay using the N2DR tokens, they will hit the transfer with N2DR. If the user wants to use the default native token for the source blockchain, has to be on the source blockchain, then they will use the right transfer button, right? So let's say the user holds NFTs on Ethereum, right? They will be, let me log in right here. They will be hitting the transfer on the right, which is basically pay with Ethereum. If they want to use their own N2DR tokens, they can use on the left. So they can hit the transfer on the left, okay? All right, let's go back. Let's go ahead and build that function. The first thing I'm going to do, check this out. I am going to paste the first 3 lines of the function so I can explain to you what they are. So I call this function retain NFT Z. C is custom. In this case, the custom pay token. So if someone decides to pay the bridging of an NFT using their N2DR tokens, they will be hitting this particular function. Again, they're not going to see this. All they're going to see is the button for N2DR, but the button to transfer using N2DR will be associated to the retain NFT C, which is the custom, okay? Next, I am going to have the token ID for that particular NFT. So if the user decides to transfer NFT 10, I will be injecting that value under token ID, so I know which NFT is the bridge going to attempt to transfer onto the vault, okay? It's a public function. It's payable because the user will be sending tokens to pay for this transaction fee and non-reentrant. So we are applying the security of reentrancy guard onto this function, okay? Message value. The first thing is, obviously, I need to know that the user has enough tokens to pay for this bridging, okay? So if the user decides to use N2the R, he or she must have at least one N2the R to make this transaction, okay? Second, I need to know if you own that NFT. Why we want to know that? Because someone will say, well, of course, he is holding the NFT in the wallet. I need to know if you own token ID 10 from the NFT collection that I am allowing you to transfer or bridge, okay? So we don't want to have anyone going smart on us and transferring any NFT from any other collection and receiving the NFT from our own collection in the destination. We don't want that. So what I'm gonna do, I first need to call the NFT smart contract itself and verify, hey, is message sender, again, the user that hit this function, the owner of the token ID that he or she is intending to move onto the bridge? If so, continue on to the next one. If not, then just throw a message, NFT is not yours, buddy, okay? In the third requirement, I need to make sure that the NFT that I'm moving onto the vault has not been already transferred. So if the NFT it's transferred, okay, so if the NFT has already been stored in the vault and it's already there, then I am not going to allow it because, again, I'm not going to allow two equal NFTs, right? And also the reason why you want to do that is for security purposes. And finally, obviously, we're not here to do any charity. We are expecting the user to pay for the bridging service, okay? So they're going to use a pay token. They're going to transfer from message sender, my wallet, I am the user who's hitting this function, to the address, this. What is this? The custody, this particular smart contract. I am transferring from my wallet, message sender, onto this particular smart contract, okay? And I will be transferring the value of this particular function call or the bridging using the custom ERC20 token, in this case, the N2the R. So in this case, I will be sending from my wallet to this contract one N2the R token because this is the price that I put in the smart contract, okay? Good so far? Awesome. We paid. Now it's up to us to do the magic, okay? The magic will be, I am going to generate an entry on the vault, okay? And we mentioned that the name, the public mapping for this vault called custody is hold custody. Hold custody for token ID. What token ID is? The token ID that the user has transferred or deposited into the vault, okay? So if it's token 10, then I will be making an entry for token 10. What information am I going to store in the custody itself, in the struct? I am going to store token ID, that will be the first value, and second, the address of the wallet of who initiated this function, okay? So this will tell me that's the owner of the token. You see where I'm going? Token owner, the second information that I will be storing in the smart contract, okay? Awesome. And we are going to finally tell the end user, hey, NFT transfer from. I will be telling the end user, hey, please transfer the NFT to the vault, okay? So the user will have to click his MetaMask wallet and approve the transfer, okay? Once I obtain approval and I get that NFT onto the smart contract, right, onto the vault, I will be emitting an event. The event will be called from the NFT custody event that I'm just registered on the smart contract. Token ID, what's the token ID? The NFT that the user has transferred. And the message sender, because I want to make sure that I am certifying that that was the address in the custody, and I am storing that value onto the custody itself. That's it. This is how we retain an NFT on the bridge. Okay, let's do the same thing. And we're almost done with the custody smart contract. Okay, let's do the same thing. But in this case, we're going to use the native crypto for payment instead of the custom ERC20 token. I am going to paste the complete function because it's literally the same. There's only one thing that changes. Okay, so now instead of C, which is the custom ERC20 token, I will be accepting the native ERC20 token. If we're using Ethereum, I will be accepting Ethereum as payment, and I will be asking for this value in Ethereum. Okay, if you're deploying this on Polygon, then it will be on Polygon. Okay, and I will be asking the same thing. Now the difference is I am going to request that you have enough to cover the transaction fee, the bridging fee, in this case, the cost native. So I want to make sure that you do have that. Okay, once you do that, message value equal cost native, I am going to request you to pay for the bridging service. Okay, so once you transfer that money, then we go on and continue. Okay, I will be checking, are you the owner of token ID? And this will be the token ID. Everything else, the same. Okay, the only difference is instead of us asking for the money as the custom fee, we will be calling a native payable transfer this amount. So in this case, I am effectively telling the user, send me the bridging fee in Ethereum. In this case, if they're using Ethereum as their source blockchain, okay? And to the smart contract. So I will be storing the fees into my custody smart contract. So once I want to withdraw that money, I can go ahead and call a withdraw function in the smart contract and obtain the ERC earnings, okay? Everything else the same. Literally, after I get confirmation that the user has paid, then I will be proceeding to, hold the NFT in custody, do the transfer, and so forth. Good so far. Now, okay, check this out. I will need to do the following. This is kind of tricky, so please pay attention to this very carefully. I need to have a function separate, okay, in case the owner of that NFT has changed. I moved my NFT from Ethereum to Binance. I sold the NFT on Binance. The new owner wants to move that NFT back onto Ethereum, okay? Wants to move the NFT back to Ethereum. Remember what happened when we initially retained the NFT onto the custody smart contract? I stored the wallet of the user who transferred that NFT as the owner of that NFT. But guess what? He sold the bridge NFT. He didn't sell the original NFT. He sold the bridge NFT. But that's no problem because we're holding the original NFT in the custody contract. What I have to do, the moment the new owner decides to move the NFT from Binance to any other blockchain, Polygon, even the native blockchain, in this case Ethereum, right? The moment they move that NFT, if we see that the owner has changed, I will be calling a conditional function, and you're going to see that on JavaScript. On JS, I will be calling a condition. If owner not equal to owner in the custody, then update owner. See where I'm going, okay? Token ID, that's the NFT ID, and the new holder. So what I'm going to do, I am not going to delete this custody. What I'm going to do instead is that the moment that user decides to move the NFT back onto a different blockchain, I will check if the owner has changed. If the owner changed, then I will be updating that in the custody contract. And I'm not going to do that only in this particular custody contract. I will be doing that on all my custody contracts across all the blockchains that are participating in the bridge, because we want to make sure that everyone has an update that particular NFT now belongs to a different owner. Okay. Once we're done with that, we will go ahead and emit the same event. But in this case, what I'm effectively doing, I'm just updating the address of the holder to the new holder. That's all. And you might be wondering, well, what if that owner, somehow it's not the owner, or something happened on the destination that the owner, there was some exploit, I don't know, something that owner not necessarily is a real owner. No, don't worry. Because if I compare and for some reason they're not matching, I still will do NFT owner of. So I want to make sure that that owner was registered in the Bridge NFT contract as the new owner, because there was a transaction that changed ownership from one user to another. You see where I'm going? It doesn't change. The principle doesn't change because I'm doing a normal ERC 721 transfer. So the original NFT collection smart contract, or in this case, the Bridge NFT collection smart contract, it's just going to update as it's normally do, okay? See where I'm going? So no problem on that side. And we want to finally release the NFT.
Release the NFT at the destination blockchain. We need to code a second function that will release the NFT stored in the destination custodial vault smart contract to the user's wallet. Very important. This process needs to be done in a sequential order to avoid a fatal double transfer, meaning that until the bridge receives confirmation that the NFT has been held in custody at the source custodial vault smart contract, the bridge will not release the NFT from the destination vault. This security mechanism will be developed in the Bridge JavaScript web application. The custodial smart contracts will update the owner addresses in the vault accordingly, once the transfer has been successfully executed.
Let me tell you about this one. You have to make sure that you, as the owner of the smart contract, can release NFTs from the vault and no one else. So you are applying only owner to release NFT, okay? Also, this is a function that must be called at the destination custody, not the source, because if you call this from the source, you are effectively releasing the source NFT, and that will be an issue. So you have to make sure that this function gets called at the release NFT on the destination blockchain. This is a call at the destination, okay? Let's go ahead and configure two more things. The last two things that I'm going to configure, first of all, I'm going to configure a function that is very general. This is to avoid anyone from transferring an NFT to the custody smart contract without calling the retain NFT. So like if I'm allowing anyone, if anyone wants to transfer an NFT, they need to do it with the retain. So this is like the security mechanism, because if someone decides to transfer an NFT without calling this function, they are going to lose the NFT. And we don't want that to happen, right? Also, there's not going to be any records that an NFT was held in the vault because they're bypassing this function. So that's why we're adding this on ERC 721 receive. This is very generic. I am going to make sure that I am not going to allow anyone to transfer NFTs using this function, okay? And lastly, the two functions that I'm going to add, basically to allow the owner of this smart contract to withdraw the earnings from the bridging. So any time that someone used the bridge, we are going to charge a fee for bridging services. That fee will be stored in the smart contract, okay? So we need to have a function that we can use to withdraw those funds onto the owner of this smart contract. Okay, not everyone. So that's why we need to make sure that we use this particular attribute, only owner, okay? And I have two functions. One is custom, because we are going to accept the custom ERC20 token, the N to the R, and we are also obviously allowing users to pay using the native ERC20 token in the blockchain, okay? Cool. And that's it. I think we're done. I got to close this thing here and we're done with this one. Now let's go ahead and build the Bridge NFT smart contract. It's very, very straightforward. It's literally the NFT collection smart contract. There's no different from a normal ERC 721 collection smart contract. The only difference is that I am going to make sure that the owner of the bridge is the only one that can call that smart contract, because we don't want users minting NFTs from that collection. Okay, let's go ahead and do that.
Let's build the Bridge NFT smart contract. A Bridge NFT is required at the destination blockchain. Let's code a smart contract that will, number 1, mint a duplicated NFT to be transferred to the user at the destination blockchain. This is the NFT that will be transferred to the user's wallet after obtaining possession of a bridge user's original NFT in the custodial smart contract. And number 2, it allows the transfer by the custody contract of that NFT to the user's wallet. Bridge NFT Smart Contract Parameters. This is a normal NFT ERC-721 smart contract with certain enhancements. Do not add NFT minting costs. Why we would charge the bridge to mint an NFT? Security. Only allow the bridge NFT contract owner to mint NFTs. We cannot allow end users to directly call this smart contract and mint NFTs. The smart contract can allow custom NFT IDs to be minted. Imagine if a user decides to bridge NFT with ID 1000, we must mint that NFT ID at the destination blockchain and not NFTs in order as a normal NFT collection smart contract.
Okay, so let's go ahead and build the Bridge NFT smart contract. Again, this is a smart contract that will mint tokens at the destination blockchain. Very important, this smart contract can only be called by the owner of the bridge or the owner of the contract itself, no one else. Like, we're not going to allow anyone to mint NFTs using this smart contract. And also, we're not going to charge the bridge for minting fees, right? So we're not going to charge any NFT minting fees. We are just going to allow the bridge to mint NFTs on the fly. If the user decides to bridge NFT 50, the smart contract will be configured to allow the bridge to specifically mint token IDs. So we want to allow the bridge to mint NFTs randomly instead of how we deploy a normal ERC 1155 or ERC 721 smart contract, in which as user starts minting, you issue tokens in order. No, in this case, we cannot, because we need to allow the bridge to randomly mint IDs, okay, and issue the destination token that way, okay? So with that said, let's go ahead and do that. So what I'm going to do, I am literally copy and pasting the NFT collection that I already have on GitHub, NFT collection smart contract, okay? So now let me add certain parameters. So let me explain that to you. I am literally doing the same smart contract. This is no difference. Okay, so this is just NFT, enumerable, ownable, strings. The only difference is I don't have a cost for the NFT because I'm not going to charge the bridge to mint. However, very important. So if you already have an NFT collection that you're already deployed, you want to make sure that you make this smart contract the same, okay? Because if you have 8,000 NFTs on a collection, you are going to add 8,000 NFTs as max supply. So then the smart contract has the exact amount of NFTs as the source, okay? And the base URI, of course, the metadata, make sure that, this will be the base URI that points to your NFT metadata. Make sure that you update that with your own values, okay? And this is where the magic happens. This is the only function that I want you to pay attention right here, okay? Bridge mint. It's very straightforward. If you can see here, only the owner of the smart contract can mint, no one else, okay? I am going to, first of all, request 2, because I need to make sure that I can send that NFT to the custody smart contract, okay? So first of all, I am going to send that to the owner wallet, okay? I am going to send that to the owner wallet. But from the owner wallet, we will then transfer that to the custody smart contract, right? And you might say, well, why we want to do that? The reason we want to do that is because we want to have record that the first time someone moved that NFT was a user and we update their wallet in the vault. You're going to see this in the third video. In the third video, we're going to build that magic Java script function that, trust me, it's very long, but it will make this a reality, okay? Cool. So I got address 2. This will be the destination for this bridge mint. So every time that I call this this minting function, I am going to send that to a destination address. In this case, will be the custodial contract. And the token ID will be the token ID that I will be minting, okay? This is very different from a normal ERC-721 NFT collection smart contract in which you just mint, as people come and users buy NFTs, you mint 1, 2, 3, 4, in order, right? In this case, I am not doing that. I am actually minting random numbers. If someone decides to bridge NFT 50, I need to make sure that the NFT that I'm going to mint at the destination is NFT 50. And I will be minting it once because that's the NFT. What's going to happen? The user decides to bridge it back to another blockchain. Then I will hold that NFT in custody and I don't need to remint. I already have it. Okay. See where I'm going? Cool. Also the mint. Obviously, it's very straightforward. I'm just calling the mint function, ERC721 mint to, that will be to the address and the token ID. That's all I'm doing. Nothing else. Make sure that it's only callable by the owner of the smart contract. Because you don't want anyone minting NFTs here. First of all, they're free because we're not charging anything. And second of all, they're basically meant to bridge the tokens. That's all they're doing. Okay, and that's it. So what I'm going to do, I am going to add all the other parameters, which are very, straightforward on ERC721. And we got to make sure that we have them because we're going to use them in Java, in the JavaScript function, right? So the token URI, give me the token URI, the wallet of owner. I need to know who the owner of that NFT is. That's very important, actually. But this is very generic. This is very straightforward. Normal on ERC721 smart contracts. I want to know who's the owner of that NFT and so forth, okay? And that's it. All the other parameters are very generic, okay? So we're set with this. Let me go to Remix. I'm going to deploy this on the Java VM. So we're not going to even deploy this on testnet. There's no purpose. I just want to show you that we can actually mint random numbers, okay? Or random NFTs. So let me go ahead and grab that. I'm going to copy the entire thing, right? Okay, we're going to create a new file called NFT sold. Cool. We're going to paste this in. Okay, and this is literally the same smart contract. There's no difference. The only difference is this magic function right here. Okay, and let me go ahead and compile. Cool, no errors. And we're just going to use the London Fork Remix Java VM. And we are going to select the NFT collection, deployed. Okay, let's play with this. So now I want to mint NFT number 600. Okay, so first of all, I gotta grab my wallet, add it in here because that's the destination. Token ID, we want to mint NFT number 60. Transact, done. I just minted NFT number 60. Remember, I haven't minted 1, 2, 3, or 4. I can randomly mint NFTs like this. Okay, now let me take a look and see how many NFTs do I have already because I minted 1, right? Now I want to know what NFT ID do I have on my wallet. Okay, so I got the wallet address. I'm going to copy it. And let me go owner, wallet of owner. So I'm going to put my wallet here, call, and I have NFT number 60. Okay, there you go. This is all we're doing. That's it. On the next video, get ready. We're doing the bridge JavaScript function. You see, we might think that building an NFT bridge sounds like a very hard or complex task. It is not. However, as long as we make sure that we have proper security mechanisms to avoid a potential breach, and we know that most of crypto exploits or crypto or blockchain attacks are done on bridges. So we need to make sure that we take a lot of caution when we deploy something like this and we apply more security features and make sure that we address any potential loopholes. Okay, and this is me giving you a demonstration or tutorial on how an NFT bridge will work. Okay, any case is different, so that's up to the developer who is intending to deploy the NFT bridge to understand what the needs are, right? But you have the idea. This is a fully functional NFT bridge, okay? And we also allowed users to pay using their custom ERC20 token, the token that we have been working so much with in this channel. So now you're giving another utility to that token. You keep adding utility to a token, you make it more valuable, okay? Crypto, and by the way, not financial advice, NFA. But as you keep adding utility to a token, there's more purpose to it, which means that we get the value increase. There's more utility in that ERC20 token, which means that, yeah, I can use this token to do X, Y, Z. I can buy other NFTs. I can use the token to pay bridge transfer. I want to move that NFT to a different blockchain. You're giving so much potential to an NFT collection by providing an ERC20 staking token or a reward token, right? So those users now, not only they can stake their NFTs, they earn ERC20 tokens because they're staking those NFTs. And on top of that, they can move those NFTs between blockchains. I'm like, that's the whole package right there. You know, an NFT should be able to float between blockchains. It earns you passive income by giving you an ERC20 token in exchange by staking the token, by staking the NFT. And also, you're giving the user the flexibility of moving that token across different blockchains. Like, what else? What else do you want? Okay. Alright, that's it for the video. I am making it very quick because we have a lot to work with. We got the Bridge NFT smart contract, and we also have the Custodial smart contract, which is very important. We have built the two smart contracts, and of course, I suggest you take a look at them. I am going to leave the link to the Github Repo so then you can take a more closer look, and we're going to prepare ourselves for the next video. On the next video, I am going to build JavaScript functions in NextJS because we need to build the JavaScript front end for this amazing application. And get ready, this is I think this is the most complex part in the NFT bridge. Once we're done with that, all we have to do is build the front end, okay? Which it's tricky, I'm not gonna lie, it's tricky, but it's not as complex as building the actual JavaScript function that is going to make all this magic happen. But that's what we're here for. And you know me, we're not stopping. We're not stopping. We're here until we can get all the way to the top. Thank you so much for your support. I truly appreciate it. Hey, if you like this video, hit the thumbs up. Subscribe if you haven't subscribed to. And we'll see you on the next video. Bye.